Now let's look at some more problem-solving quadratic inequalities. So the first example let's look at the problem solving 6x squared plus 7x less than 5. The first thing I want to do is rewrite this so that it looks like ax squared plus bx plus c is either greater than or equal to 0. In this case, less than 0. So I'm simply going to subtract 5 from both sides. 6x squared plus 7x minus 5 is less than 0. And now what we'll do is think about the steps of solving a quadratic inequality. The very first step is I'm going to find the critical values, or the x-intercepts. And the way that I'm going to do this is I'm going to factor or use quadratic formula here. I'm going to try to factor this. I'm going to use AC factoring. So if you need to see a video, look at AC factoring A not equal to 1. So the first thing I'm going to do is look at the signs. This is a positive and negative, so that means the first step is I'm going to have one positive and one negative. Second step is I'm going to multiply A times C, so that's 6 times a negative 5, so that's a minus 30. Third step is I'm going to find two numbers that multiply to minus 30 and add to a positive 7. 6 and 5 doesn't work, 10 and 3 works. So that's going to be a positive 10 and a minus 3. And I'm going to rewrite the original problem, 6x squared plus 7x minus 5. I'm going to break the middle term up into these two numbers, 6x squared plus 10x minus 3x minus 5. I'm going to factor what I can out here. Here I can factor out looks like I can factor a 2x, so that becomes 3x plus 5. A negative 3x minus 5, there's no common term. There is a negative. Since the first term is negative, I'm going to factor a minus 1 out, and then I get positive 3x plus 5. And then that's my factored problem. 2x minus 1, 3x plus 5. So the way I'm going to solve for this one is I'm going to factor it. If I wanted to, I could use quadratic formula. It wouldn't matter. So I get 2x minus 1, 3x plus 5 is less than 0. My critical values then are 2x minus 1 is equal to 0, 3x minus 5 is equal to 0. Add 1, that's going to be x is 1/2. I'm going to add 5 and add 5. I get x is equal to 3x is equal to 5, x is equal to 5/3. And that's going to be, since this is the 3x plus 5, so let's see, that's 3x plus 5, so I'm going to subtract 5 and subtract 5. So I get 3x is equal to minus 5, so that's a minus 5/3. Be careful with your signs there. If you notice I made a sign mistake originally. It's 3x plus 5, so I'm going to subtract 5 and subtract 5. So now I'm at the third step, and the third step is the critical values are x is 1/2, x is equal to minus 5/3. After I find the critical value, I'm going to do, what I'm going to do is draw a number line. Minus 5/3, 1/2, that, and I'm just going to test my problem. I'm not going to use this problem, I'm going to use this problem here. 6x squared plus 7x minus 5 is less than 0. Since it's a parabola, I know it's either going to go positive, positive, or negative, positive, negative, right? Because it's either going to go up or down. So I just need to test one point. I'm going to choose a number more negative than minus 5/3. So I'm going to choose this interval here. I'm going to choose x is equal to minus 10. So I go 6 minus 10 squared plus 7 times minus 10 minus 5. Minus 10 squared is 100, so that's 6 times 100. So that's 600 minus 70 minus 5. That's clearly going to be a positive number. It's actually going to be 525. So this is positive here. I could test a point here, x is equal to 0, and I would get 6, 0 squared, plus 7 times 0 minus 5. 0 squared is 0, that's 6 times 0 is 0, plus 0 minus 5 is negative. But actually I don't need to do that. Once I know this is positive and I know it's a parabola, then I know it's going to go like this, positive, negative, and then positive again. So those are my steps. My steps are first find the critical values and then define the critical regions and test the critical regions. The last step is let's look at the problem. Here's the problem. I want to find out those places where it's negative. Now let's look at my number line. Where is it negative? It's negative between here and here. Is it strictly less than, or is it less than? It's strictly less than, so that means these are going to be open dots and open dots. So there's my answer right there. If I want to write that in interval notation, let's look at that. It starts at minus 5/3, and it goes to a positive 1/2. It doesn't include negative 5/3, and it doesn't include 1/2. And that's my answer. Let's do one more example. In this one, let's do x squared plus 2x plus 5 is greater than or equal to 0. First thing is I'm going to find the critical value. It's already equal to 0. I'm going to go x squared plus 2x plus 5 is equal to 0. I'm going to try to factor that, and I'm not going to be able to, so I'm going to use quadratic formula. Remember, the only reason we factor is because it's often easier than the quadratic formula. X is equal to minus b plus or minus square root b squared minus 4ac over 2a. A is 1, b is 2, and c is 5. So let's plug those in. That's a minus 2 plus or minus 2 squared minus 4 times 1 times 5 over 2 times 1. That's minus 2 plus or minus square root. Be real careful underneath the square root. That's where people make mistakes. That's 4. And then that's 4 times 1 times 5 is 20. So that's 4 minus 20 over 2. That's going to be minus 2 plus or minus square root minus 16 over 2. Now this is a negative square root. Since I'm solving for x-intercepts, I already know there's no real solution, so there's no critical values. Right? So when I do my intervals, if there's no critical values, then all I have is a single number line. If I have a single number line, all I have to do is, what that means is that I'm only going to have positive values or only negative values depending on my interval. And so I'm going to test any point. Let me test x equals 1. That's an easy one to test. So that's 1 squared plus 2 times 1 plus 5. 1 squared that's 1 plus 2 plus 5. That's 8. So that means this interval, which is the only interval, is positive, which means this is always positive. Do I want positive or negative? I want positive values. So that means my answer is all real numbers. The key is we use the critical values to define the intervals. If there's no critical value, there's only one interval. So that's just like testing any point. And that's how you solve quadratic inequalities.